All right, CNT125, Chapter 11. We're going to look at some authentication technologies. These are ways that we're going to authenticate, the who are you? Who are you? And before we even let you do anything, who are you? A number of different things that can be done for this. Single sign-on is one thing that's, I'm going to say, used pretty frequently. Once you authenticate somebody, they have access, you kind of come through the front door and they have access to a couple different resources then. The prime advantage is it's convenient for the end user. The disadvantage, though, is once you've gotten in the front door, a user has access to lots of things, and if that user is a hacker, they now have access to lots of things. So it makes it easier for the hacker to, once they've gotten through that hurdle, it might take them a lot of work to get through that hurdle. Once they're in, they have access to a lot of things. But single sign-on, a lot of times to try to make this more secure, two-factor authentication is done, which a lot of us are now used to. You would provide your username and password, and then you need to provide something else along with that. Maybe a code texted to you, maybe a fingerprint, maybe some sort of other identifier to be able to access the network or the resource. Multi-factor authentication is kind of the umbrella for all of this, and here are some different things that can be done. Something like your username password, if you will. Something you have might be some sort of smart card, ATM card, or key that you might have. Something that you are, fingerprint, retinal scan, that sort of thing. Location, where you are, whether I'm in a specific building, the whole geofencing thing, or a certain subnet. Something you do may be a speech pattern. Some of us have seen this as part of different plots of spy movies and that sort of thing. Okay, but multi-factor authentication requires at least one thing from two different categories. So again, I might use my username and password as the one, and I might need to provide something else to get in, whether it's from a certain location, a fingerprint, that sort of thing. A lot of times what gets used is we might end up using some sort of authenticator. This would be maybe either a code texted to you, or you actually load an app that is giving you a code that you use. That is, I'm going to say, pretty common right now for a lot of us. Either we have a code texted to us that we put our username and password in, then we have used that code that's texted to us, or we use the Authenticator app where we plug in that number that's continually changing. Sometimes it's like every 30 seconds that number changes. Another one is a hardware-based token, like we would have down here. This got used a lot of times for anybody dealing with financial banking data type thing. This is pretty common to use. So I use my username and password, and then this code number that's continually changing all day long. Another way that authentication can be done is through directory services, things like Active Directory in Windows. With this, now we have, again, username, password, and then it's going to verify, yes, this is Doug Brown. He should be a user in here. And then once we get him in the door, that Active Directory is still consulted for what is Doug Brown allowed to do, kind of thing. But all of these options are built to be LDAP compliant, Lightweight Directory Access Protocol. That's a standard for all of these. LDAP defines rules for how you communicate with your authentication directly, so you can prove who you are. Provides rules and instructions for the process of authentication, while the authentication directory provides stored credentials. So here it gives you an idea of authentication process, and then the back end to the authentication directory. And this is showing you where that LDAP would come into play for you. So directory services. With directory services, they run into the one weakness of LDAP is it transmits user credentials in plain text. So previously, when local networks defined the perimeter of a trusted environment, this wasn't so bad. But today, you can't assume that your network is safe because this might not be in the location it used to be in. Okay, we might be doing the whole hosted thing. So instead, today's on-prem authentication processes should use more secure ports and communication, LDAP secure, if you will. Active Directory is configured to use Kerberos protocol by default. Active Directory can use LDAP instead or use both side by side. Kerberos provides authentication with the database, and LDAP provides the authorization. So the Kerberos is saying, okay, Doug Brown is logged in, and then LDAP is going to say, okay, Doug Brown's allowed to do A, B, and C. Okay, so these can actually work in conjunction with each other. So they remind us now of Kerberos. And I just put up the little Greek three-headed dog up there just to kind of jog your memory on that. This is now authentication protocol configured by default in Active Directory. Cross-platform, uses key encryption to verify identity of clients, exchange information, and private key encryption service considered especially secure by today's standards, if you will. Does not automatically trust clients, but it's going to require clients to prove identity through a third party. Kerberos communications are encrypted, and you have principal, key distribution center, and ticket. So now they're going to introduce the idea of a ticket of like, okay, once I have authenticated ticket, then I can have access to. So if I take a peek here, the user, I do the authentication service right here, the authentication service. Okay. Hey, can I get a ticket, please, if you will? It's like, okay, and it's going to authenticate Doug Brown and password, if you will. It's like, okay, here's a ticket. Now the ticket is, okay, I'm going to go to your ticket granting service, issues tickets to an authenticated client. So now we're fully authenticated, and now with the authentication, it's going to say you actually have access to this service or this storage, if you will, this utility, this application. So it's a double check. It's a double check. All right, another authentication service, if you will, Radius, Remote Authentication Dial-in User Service. Environments with many simultaneous connections, several user IDs, passwords, centralized service to manage these across all these functions. Radius can be used. Most popular AAA service is Radius. It was open source, standard developed in late 90s, early 90s, if you will, later standardized by Internet Engineering Task Force. With this one, cross-platform, open source, runs at the application layer, can use UDP or TCP. It can operate as an application on a remote access server or a dedicated Radius server. A lot of times you'll see Radius gets used for authenticating like wireless users type thing. Highly scalable and can be used to authenticate wireless mobile remote users. It really started off as remote users, and then as wireless came along, kind of got adapted to be used for authenticating your wireless or moving around mobile users, if you will. Radius servers are often combined with other network services running on a single machine, so it doesn't always have to be a separate standalone Radius server. And here's Radius server authenticating a bunch of different services running in a network. Here, Radius and Active Directory can be working together, so I can use the Radius server to authenticate the wireless users, LDAP in here to be like, okay, what do you have access to? Another authentication is your Terminal Access Controller Access Control System Plus. Again, another AAA protocol. Here, and obviously admin options separating out authentication, authorization, and auditing capabilities, your accounting capabilities. Differs from Radius in that it relies on TCP, not UDP at the transport layer. Developed by Cisco for proprietary use. Typically used to authenticate to network devices such as routers and switches rather than workstations or servers. So most often used for device administration access control for technicians. Can be used for resources for other users, but typically that's what it gets used for. Third-party identity providers. A service that provides authentication services, stores user credentials. Cloud, web, and mobile applications often rely on this for authentication services. Generally used to refer to an authentication provider that is designed to support off-site authentication. So, trust relationship, to establish this trust relationship between website or application, needs some kind of standard to define rules, communications, and so forth. This is your security assertion markup language. User authenticates with the identity provider. The identity provider sends the authentication token to the service provider, such as a website or mobile app. And the service provider never accesses the actual user credentials. It's just saying, yes, they've been cleared, go ahead. Using identity provider offers the service provider the following advantages. Improved user experience. User can sign in with their existing credentials, reduce user support. The service provider doesn't have to support those users with forgotten passwords. That's somebody else's job, if you will. Secure credential storage. Identity provider establishes a high level of security for storing all this. And sophisticated authentication. Identity provider often incorporate options for more sophisticated authentication processes, including like multi-factor authentication, if you will. Now, at this point in the chapter, they actually had a chart to kind of try to sum up a lot of the encryption authentication methods. So I tried to put it here as a chart in case you wanted to save these for yourself. Trying to show a bunch of different things they mentioned over time in one kind of, clear table, if you will. So hopefully that could be a useful set of notes for you. Some of the last topics are more of the models of security, if you will. Zero trust security. With zero trust, this is kind of what a lot of places have gone to with maintaining security with their users, devices, and remote access and so forth. So many strategies of securing the network perimeter, the edges of the network that separate your protected network space from the outside world. Firewalls are going to filter your traffic to restrict what traffic is allowed inside the perimeter. Proxy servers represent internal resources when communicating with external services. And your remote access protocols support external users with secure access to the organization's network. So, with zero trust security, this approach to security becomes inadequate, just relying on those, because I might have network services that are hosted, a web server, web application in the cloud. So they're not behind our perimeter anymore. They're outside of our perimeter, but we still need to somehow secure them. So a cloud customer has little control over that. What resides in the cloud exists outside the organization's security perimeter, and therefore these must be protected in other ways, which I was just mentioning to you. Traditionally, once an entity gained access to the internal network, it was assumed to be trustworthy. That's no longer the case anymore. Since these edges have softened, expanded, even disappeared in some cases, inside of a binary inside-outside, versus outside approach security, cloud native security strategies attached security to individual resources. So instead of this binary inside-outside, it's kind of like it's attached to everything. Everything is kind of considered not trustworthy until it's verified, and that's the mantra here. Never trust, always verify, as people are moving inside outside your perimeter. So with this, relies on the following principle: attack surfaces. Resources are individually protected rather than defining a larger group. Resources isolated from each other, from other resources by requiring authenticated communication between them. Yes. Authentication processes are implemented throughout the organization and even between network resources. Access management, determination of access, authorization are made based on a wide variety of context. And observability, every request is logged and all traffic is inspected. So it's kind of the whole, everything's going to be double checked and authenticated as it moves about. And that's, I think they even show you here with a virtual private cloud. Security will have granular filtering for individual interfaces, while your network access control list filter traffic for an entire subnet. And one of the last things they mentioned for us is SASE, Secure Access Service Edge. It's a theoretical model that merges software-defined networking services, zero trust security, into a single framework. So here, all core components now, with our networking and our security, it's kind of like merging those two, if you will. The security side of the framework, collectively referred to as your service security service edge, creates many security services that protect your distributed resources. The following are some of the core components: your zero trust network access, your cloud access security broker, your firewall as a service, and secure web gateway. These are all part of it now. Okay. So familiarity would be the key on these aspects of kind of a network security model or framework, if you will. And there's the end of our Chapter 11.